Hi, this is Raphael Mudge. Welcome to Part 7 of Red Team Operations with Cobalt Strike, Privilege Escalation. In this lecture, we're going to talk about different ways to elevate privileges within Beacon. We will talk about exploits and elevators, which is Beacon's elevate and RunAsAdmin commands. We will talk about elevating with misconfigurations and credentials. We will also go into two situations called bypass UAC and get system. We will talk about credential and hash harvesting, and we will talk about how to use Mimikatz in Beacon as well. Use the elevate command to run a Beacon payload in an elevated session. Type elevate in a Beacon console to see a list of privilege escalation options registered with Cobalt Strike. To spawn an elevated session, run elevate module name listener in a Beacon console. Choose your listener, choose your exploit, and press launch. Use RunAsAdmin to run a command in an elevated context with a command elevator. To see the command elevators registered with Cobalt Strike, type RunAsAdmin in a Beacon console. To run a command in an elevated context, use RunAsAdmin, the module, the command, and arguments. And you may be asking, why do we have two different ways to elevate in Cobalt Strike's Beacon? What is the difference between elevate and RunAsAdmin? Well, let me take a shot at explaining that. Elevate is to spawn an elevated session. Some privilege escalation tools present a very natural opportunity to pass execution to shellcode. For example, if our privilege escalation exploit results in a new token that we can apply to the current thread, it makes sense to pass execution to a payload and let things go from there. Some privilege escalation opportunities only give us a primitive to run a command in an elevated context. Rather than dictate how to turn that into a session, Cobalt Strike is instead taking the approach of bring your own weaponization. This means you get to choose how to use this primitive in a way that makes sense for your situation. For example, maybe you just want to run one command to weaken the target or meet your objective. RunAsAdmin can do that. Or maybe you think you can get away with dropping an executable to disk and running it in an elevated context with RunAsAdmin. That's an absolutely fine way to spawn a session. Or maybe you don't want to touch disk and you decide it's okay to plug your nose and use a PowerShell one-liner. You can do that with RunAsAdmin as well. Right-click on a session, go to Access One-Liner, and this will give you back a PowerShell one-liner that is tied to a download cradle that will pull a Beacon payload from within your current Beacon session. It won't leave the target. So that is something that you can combine with RunAsAdmin to create a session. The main point with RunAsAdmin is you get a choice in how to use that primitive to benefit your operation and objectives without having to buy into a chain of events and automation forced on you by your tool developer, in this case me. When you run RunAsAdmin or elevate, you will probably notice there are not too many options. Cobalt Strike does not have many organic privilege escalation tools. That is not the point of the tool set. You can register a privilege escalation tool through Aggressor script. And if you want to learn how to do that, take a look at the Elevate Kit. The Elevate Kit demonstrates how to use third-party privilege escalation attacks with Cobalt Strike's Beacon payload. What do I mean by third-party exploit? Well, let me take you through an example. Here is the Ruby code for a Metasploit Framework module for the MS-15051 privilege escalation exploit. I know this is a very old exploit, but it demonstrates the pattern that I want you to see. In this case, the exploit is not written in Ruby. The exploit logic is written in C and compiled as a memory injectable DLL. That is CVE 2015-1701 x86 and x64.dll. Now that we know the exploit logic is compiled into a memory injectable DLL, I hope you're asking, how does Metasploit run this DLL via Meterpreter? You don't have to look very far for an answer. That's what the code in front of us does. First, the module runs notepad.exe. It then opens a handle to this temporary process and it copies the exploit DLL and our payload stager over to that new process. It then creates a thread that runs the exploit DLL entry point and passes a pointer to our payload stager as an argument. Does this sound familiar? It should. This is fork and run. This is the same thing Cobalt Strike's beacon does to run its post-exploitation tools in a temporary process. I want to show you a function, bdllspawn. This is part of Cobalt Strike's aggressor script scripting language. As arguments, it accepts a path on your local system to a reflective DLL and a parameter to pass to that DLL. When this function is run, it tasks a beacon to run a temporary process, copy the reflective DLL and the parameter over to that temporary process, and to create or hijack a thread to run that reflective DLL entry point and pass it a pointer to the parameter. This is the exact same thing the Metasploit framework is doing in this module. The difference is bdllspawn takes advantage of your spawn2 value and other session prepping you did, and when it's doing process injection, it's following the hints in the process inject block you specified in your profile. What's really cool about this is that you can bring a Metasploit Framework privilege escalation exploit that follows this pattern over to Cobalt Strike with very, very little work. Here's what it looks like to use that same Metasploit Framework DLL from within Cobalt Strike. This example is taken from the Elevate kit. Here we have a subroutine MS-15051 exploit. We are registering it with Cobalt Strike with beacon exploit register. We provide a module name, a title, and a reference to the subroutine. Here's what this function does. It acknowledges the command and says we task beacon to run listener description via MS-15051. It then reads in the DLL that matches the architecture of our current beacon. It also generates shellcode for the payload. One thing I want to point out, we're not generating a stager. We're actually going to pass the entire payload as an argument. So we are actually using this exploit with a stageless payload, which I think is really cool. We then use bdllspawn, as promised, to pass the payload as an argument, give it a job description of MS-15051. We then allow it to block beacon for 5 seconds without giving any output. The beacon link command at the very end of this will actually task our beacon to link to the payload if it's a TCP or SMB beacon. If the listener we chose isn't either of those, beacon link doesn't do anything. So that's an example of integrating a Metasploit Framework privilege escalation exploit compiled as a reflective DLL into Cobalt Strike. Here's another example from the Elevate kit. This example integrates invoke event viewer bypass.ps1 from PowerShell Empire into Cobalt Strike's RunAsAdmin command. Here's how it works. btask announces to the Cobalt Strike beacon console that beacon has been tasked to run something $2 in a high integrity context. A high integrity context is referring to a UAC bypass. We'll talk about what that means in a moment. This script then reads in the PowerShell script from the modules folder relative to this particular script file. We then call beacon host script to host this PowerShell script within Cobalt Strike's one-time use web server. Beacon host script returns a one-liner or download cradle that will download this script from its local one-time use web server and evaluate it. And by doing that, the contents of that script and its commandlets become available wherever that download cradle is run. We then do bpowerpick to run PowerShell without PowerShell.exe. We give it our download cradle, which again makes the contents of invoke event viewer bypass available, and we call invoke event viewer bypass -command and whatever the user wanted to run. To make this available with RunAsAdmin, we call beacon elevator register with UAC event viewer, which is the name of the technique, a description, and a reference to the event viewer elevator function. And that's what it takes to integrate a exploit or privilege escalation technique that gives us a primitive to run a command. Let's take a look at privilege escalation via the Elevate kit. For this demo, we're going to interact with this Windows 7 virtual machine. It is unpatched, and I'm only using this VM to demonstrate using a memory corruption exploit. If we type Elevate by itself, you can see not too many options, okay? Same thing if we do RunAsAdmin by itself. But these are the things built into Cobalt Strike for privilege escalation. Now let's go ahead and load the Elevate kit and add to this. Go to Cobalt Strike, Script Manager, press Load, navigate to where you downloaded and extracted the Elevate kit, and load elevate.cna. Now, let's try the same thing. Control K to clear the screen. Elevate, press Enter. And here you can see we have more options. Same thing with RunAsAdmin. We have more options here as well. So that's extending the Elevate kit. Now let's go ahead and try out an exploit. We're going to do MS15051 on this Windows 7 VM. So let's do Elevate, MS1551. And normally we could tab through a listener, but what I want to do is I actually want to add one listener. We're going to add a TCP beacon listener. Let's go to Cobalt Strike script or Cobalt Strike listeners, press add, and we'll do one called local TCP. I'm going to call this privesc. You'll see why. We're going to do this one on port 9292 and bind to localhost only. Let's press save. And now we have a TCP listener for localhost only things. And let's just tab through to get that one. Press enter. And when our beacon checks in, it will run this module and pass our TCP beacon to it. And the beacon link command should take care of linking. And there you go. You can see we've escalated our privileges and we now have a system context beacon on this Windows 7 system linked through our TCP beacon. So that's an example of using the Elevate kit. Another path to escalate privileges is to look for misconfigurations and take advantage of them. A tool that can help you here is SharpUp. SharpUp is a privilege escalation misconfiguration vulnerability scanner written in C# by Will Schrader. It is part of the GhostPack repository on GitHub. To use SharpUp from Beacon, Use execute assembly, the local path to SharpUp, and the parameter all. Let's take a look at elevating with a misconfiguration. I'm going to interact with our Jim Stevens beacon on our Windows 10 system. And let's go ahead and run execute assembly. And that happens to live in GhostPack compiled binaries and SharpUp.exe. And we will run this with the option all. And SharpUp again is a tool to look for different kinds of misconfigurations. And just give that a moment to finish. And we can see that there is a service our current user, Jim Stevens, can modify. And that service is VM Tools. Normally, this service is not modifiable. I deliberately weakened the permissions of the service for this demo. But I want to show you the process. So we ran SharpUp. Now we want to modify this service to have it run our payload. So let's go ahead and export a service executable. Tax, packages, Windows executable S, listener, and we'll do the TCP beacon on port 9292. Let's do a service executable, 64-bit, generate, and we will call this vmtoolsd.exe. Now let's grab the service name, put that in our clipboard, and let's go to a folder that we can write to. And let's upload our vmtoolsd file. Now we want to modify the service. Let's do this. Let's do run scconfig vmtools bin path equals C users Jim Stevens downloads, because right, that's the best place to put it. Not really, but we're going to use that. So vmtools.exe looks okay to me. Let's do run sc start vmtools, and our beacon checked in, stop the service, and the start is pending. And you may be thinking, okay, cool. Where's our beacon? We ran a TCP beacon that we need to connect to. Because we're doing this outside of any automation, we have to issue a connect command manually. So let's go ahead and connect and assume control of our beacon. So let's do connect 127.0.0.1, and we can tab complete the port. So 9292, and if all goes well, there we go. We have a system beacon. So that is an example of elevating with a misconfiguration. Another way to escalate privileges is to use credentials to spawn a session as another user. This other user might be an administrator or have administrator rights, or just have the rights to do what you want to be able to do. To use credentials to spawn a session as another user, right-click on Beacon, go to Access Spawn As. You can also use the Spawn As command within the Beacon console. A few things. First, make sure you pay attention to the current directory. If you are in a directory that your beacon cannot read, or that the new context, the new session cannot read, this command is going to fail. So that's one thing, and that usually gets people. Another one, I mentioned that Beacon's command parser is position-based. Still true. If you run into a situation where you need to use, say, a username with spaces in it, you can do that with the spawn as dialog, but not with the console, because the console won't parse it right. I used to do a lot of assume breach cyber defense exercises, and in those contexts, I often had administrator credentials to work with, either for a local administrator or even a domain admin. I know personally, in those contexts, spawn as and its simpler counterpart, run as, are invaluable. So this is a good capability to be aware of. Let's take a look at spawn as. Here we are in Cobalt Strike. First thing I'm going to do is interact with this beacon and I'm going to change it to another folder, somewhere that I know I can write to or read, I should say, and that my target user context can read as well. We're just going to do right-click, access spawn as, and we're going to use the creds for the local administrator account, which I enabled for this demo. Very common in cyber defense exercises. We're just going to do demo pass, 1, 2, 3, 4, bang. We're going to put a period for the domain value, and that means use a local account. We'll choose our listener, and I think the TCP beacon is working fine for us. We'll use that. Let's hit launch. And if all goes well, there we are. We now have a new beacon running as the user administrator. I do want to touch on Kerberoasting. This is a really cool technique to potentially recover privileged credentials from an unprivileged context. This technique was first described at SANS Hackfest 2014 by Tim Medine, who I understand is also the originator or inventor of this technique. Here's the idea. Some services are run with a domain user as their service logon account. And by service, think mail server, web server, SQL server. And sometimes these accounts are privileged, maybe on the system that the service is running on, or even as a domain administrator. To enable Kerberos authentication, these service logon accounts are associated with the service via something called a service principal name, which is set up on the domain controller. Now, when I, an end user on a network, want to authenticate to a service on that same network using Kerberos, I go to the DC with my ticket granting ticket and I say, hey DC, can I get a ticket granting service ticket for that target service on that target system? And the DC will give me back this ticket. Now, what's really interesting is that this ticket granting service ticket, parts of it are encrypted with the domain user's password hash. With that out of the way, let's go into the Kerberoasting attack. From our unprivileged context, we can query the domain controller for account objects with SPNs. Once we have these SPNs, we can request a ticket granting service ticket for each associated service from the domain controller. Once we have that ticket, which happens to have sections encrypted with a key derived from the user's password, we can try to recover that password by cracking that ticket. That is the Kerberoasting attack. Let's try out Kerberoasting. I'm going to interact with my Jim Stevens beacon, and we are going to run a tool called Rubius, which happens to implement a lot of options for Kerberoasting and doing other things with Kerberos in general. Again, this is another tool by Will Schrader. I should just call this Red Team Operations with Will Schrader's tools. It halfway feels like it, doesn't it? Will's definitely a very, very prolific developer in this space. All right, so we're going to execute assembly, GOES-PAT compiled binaries, rubius.exe, and we're going to do Kerberoast. And we're going to do an out file. Let's get to a folder we can write to, actually. Let's go to users, Jim Stevens, downloads. Let's make sure we're there. All right, good. Now, let's do that. Let's do execute assembly, Kerberoast, out file, hashes.txt. And what this is going to do is query the DC, look for any accounts with SPNs, and report that back to us. And it's going to request the ticket granting service ticket as well and save that information to hashes.txt. You can see that we do have one. This is SQLadmin. I actually installed a Microsoft SQL server in this network, and I have it running as the domain user account SQLadmin. All right, so let's download hashes.txt just to bring that over to our Cobalt Strike team server. And let's get rid of the file from this system with the rm command to remove it. Now let's go to View, Downloads, and there's our hashes.txt. Let's do sync files to bring that over to our home folder. Cool. Now let's go ahead and take a whack at cracking this file. Let's come over here to a terminal, and if we look, here's the content of our hashes.txt file. Now I'm just going to use a very kind of contrived example of going through a word list with no permutations or anything else. So we're going to output to the crack.txt file. We're going to use hashes.txt as our hashes, and we will use the rocku word list. That looks okay. Let's let that run. And we're just going to let it go and do its thing. If I want to, I could press S for a status, but we're done. And we can see that the hash is indeed cracked. That's the status. And if we look at the file cracked.txt, we can see that our hash, and we can see at the very end the password, which happens to be I am the admin $$$22. This is a contrived example because that is a password that was in this file in the rocku word list. Now, just to kind of bring it all back to using Cobalt Strike, let me show you how we can try to elevate with those credentials using the spawn as command. So let's do spawn as, and the domain happens to be corp. So we're going to do spawn as corp SQL admin, the credentials, and we will use our TCP beacon. And just give it a moment. And if all goes well, we will end up with a session. As Tom Petty used to sing, the waiting is the hardest part. But actually this failed, and that's a good thing. I wanted it to fail because I want you to see something. We get back this mysterious error 267. Oh man, what happened? What went wrong? What did we do wrong? Well, let's do net help message to learn a little bit about this error. And we get the directory name is invalid. This is that error you get when you happen to be in a folder that your target process can't read. Remember that warning on the slide before the last demo? Yeah, that's why I give you that warning. So let's do this. Let's go to C:/ and let's try this again. I think seeing failure is as important as seeing success, so you can see what's going on. All right, and there you have it. We now have a new beacon chained through Jim Stevens running as the user SQL admin. All right, I want to walk through the privilege escalation problem set. Most commonly, you might think of it as no rights or privileges to anything better. And in that case, you're stuck dealing with exploits, misconfigurations, and credentials. But I want to talk about two situations that are a subset of the escalation problem set that you may encounter. The first one is when you are in the context of an administrator user, but for some reason you don't have administrator rights. I want to talk about that as an escalation situation. And I want to talk about what happens when you are in an elevated context. You think you have full rights, but you can't do what you want to do. And I want to talk about why that might be and how to escalate out of that as well. If you come from a Unix background, you might be used to this idea that your user, your account, dictates what you can and can't do. If you're root, you can do everything. If you're a normal user, you can do nothing. And there's not really much of an in-between. Windows is a bit more nuanced than that. And I know when I was learning this stuff, and hell, as I'm still learning this stuff, I find that aspect of Windows very confusing. One of the technologies in Windows that is part of its access control model is user account control. User account control is a collection of technologies introduced in Windows Vista to wean Windows XP users off of doing everything with an administrator account. One of the ideas with user account control is that a process context has a concept of process integrity. And you may have heard of low, medium, and high integrity process context. A medium integrity process context is one that has standard user rights. A high integrity process context is one that has administrator rights. Thanks to UAC, it is possible that your current user may be an administrator on the current system, but everything they do runs in a medium integrity or standard user context. And if that person wants to do something with their full rights, they have to take a step to explicitly elevate to assume those full rights. And that is the UAC prompt that you're used to seeing. You know what I'm talking about? It's that dialog that says, hey, this application would like to change the system. Do you want to allow that? So for us, as a simulated adversary, if we are in a standard user context and we want to assume full rights without a prompt, that is called a bypass UAC scenario because we are trying to bypass that UAC prompting. If you want to get some situational awareness about your current process context, run whoami/groups. This will tell you which groups you are in and which integrity level your process is running at. In this output, I can see that my current user is in the administrators group, but we are currently in a medium integrity context. This means that there's potential to assume those full rights, but in my current context, I do not have them. So let's say you are an administrator user, but you are in a medium integrity context and you want to elevate to assume administrator rights and bypass UAC. You may be asking, how do you do it? And I'm going to talk about some options. You can see them on this slide. But what I really want to talk about, what I find interesting, is why it's possible to bypass UAC at all. Here's the story there. When Windows Vista came out, there wasn't really the opportunity to bypass UAC. And the reason for that is Windows Vista prompted the user for everything. Every time an application, even if the user wasn't aware that it would do so, every time the application needed administrator rights, it would prompt the user. And Windows Vista ended up with a semi-sour reception because it was prompting users for everything all the time, nonstop. And Microsoft decided to address this in Windows 7. And what they did is basically introduced options to give their own technologies auto-elevate rights, where these technologies could, in certain situations, go from a medium integrity to a high integrity context without the user being prompted or even being aware that that was happening. And this concept of auto-elevating technologies baked into Windows in all kinds of different places create loopholes that allow us to bypass UAC. So that's what's happening. Two options immediately available in Cobalt Strike that you might want to look at are UAC token duplication, that's an elevate option, and this will run a listener. It's also available via RunAsAdmin to run a command in a high integrity context. This option was addressed in Windows 10 Redstone 5, but what's really neat about it is that it doesn't really do anything that is a noisy system activity to assume these full rights. So where you can use it, it is an attractive option. Be aware that the privileged context you end up in will be very restricted. It will not be able to do many of the things that you think you should be able to do. For example, it cannot interact with processes in other desktop sessions. This idea that you have high integrity context and should be able to do certain things but can't is what we're going to talk about more after the next demo. Another option baked into Cobalt Strike is UAC CSMTP Lua, and that is a RunAsAdmin option. What this takes advantage of is a COM object that auto-elevates to high integrity in some process context. The module will call a method on this elevated COM object that will run whatever command we want in a high integrity context. It's a perfect fit for the RunAsAdmin command. Now, it's very possible in the near future that that option may not be useful to you. Great. Look at the Elevate kit. There may be something in there. Or find something else that's just floating around online and bring it into Cobalt Strike via the patterns I demonstrated in the Elevate kit. This extensibility to bring things into Cobalt Strike quickly is certainly there to allow you to adapt things as they become known and available. Let's take a look at Bypass UAC. Here I have two beacons. I have my foothold beacon as Jim Stevens, and I have an SQL admin beacon that I gained by Kerberoasting and using spawn as to create a new session. Let's go Cobalt Strike visualization pivot graph to make this chaining a little bit more clear. All right, now let's look at Bypass UAC. If we right click, go to interact, we can do who am I, whack groups with Jim Stevens to learn a little bit about our context. We can see that Jim Stevens is a normal user, not an administrator, and we are in a medium integrity context. You kind of know that by default because when you are in a high integrity context, Cobalt Strike will give you a visual cue. The monitor will turn red with lightning bolts, and there will be a star next to the username. So that's one way you know if you're in a high integrity context. All right, so Jim Stevens is no go for us. Let's look at SQL admin. Let's do who am I, whack groups, and just wait for our parent beacon to check in. And we are in a medium integrity context, we know that. But if we look up, we can see that this user is actually an administrator, a domain administrator, no kidding. But they are somebody who can administer this computer. All right, great. Well, we want to assume the rights of a high integrity context. So let's bypass UAC. We can use RunAsAdmin here, and we'll use the UAC CSMTP Lua option. Now, you remember when I talked about RunAsAdmin, I described it as bring your own weaponization. So what we're going to do, whether it's the best option or not, is we're going to use a PowerShell one-liner to give us a session, an elevated session. So let's do this. Let's go Access, right-click Access, one-liner. We'll do our TCP beacon again, and we're going to use a 32-bit beacon, and I'll tell you why. Our SQL admin beacon is in a 32-bit context, and therefore a 32-bit PowerShell one-liner has the most chance of success. Because if the 32-bit PowerShell is in your path and you try to do a 64-bit payload, it's not going to work unless you specify the full path to the 64-bit PowerShell. So we're just going to do 32-bit right now. Hit launch, and we get back a PowerShell one-liner. And let's do RunAsAdmin, UAC CSMTP Lua, paste in the one-liner. And now we'll wait for that to take. And no complaints, it's good. And let's go ahead and just try connecting to localhost 127.0.0.1, port 9292. And this is to assume control of the beacon we ran. And there you go. We now have a SQL admin beacon in a high integrity context. And again, you can tell we're high integrity because of the star next to the username and the red monitor with lightning bolts around it. By the way, if we click over here back to the sessions table, you can see there's our red monitor queue, our star. And over here to the pivot graph, same thing. So that's an example of bypass UAC. I brought up the idea that the access control and privilege model in Windows is very different from Unix, which is something many of us are used to. One of the ideas in Windows that is very different is the concept of the access token. The access token is a data structure managed within LSASS that dictates what you can and can't do. Every process has an access token associated with it. It is even possible for threads to have a different access token than their process. And that thread might be more privileged, it might be a different user, or it might be less privileged. Access tokens happen to identify with a certain user and groups. They also may include restrictions, things that the current token can't do, even though that user or group may be able to do those things by default. Access tokens also have a reference to something called a logon session that contains the credentials that will authenticate you to a remote resource on the network. We'll talk about that during lateral movement. Another thing access tokens have is a list of something called privileges. Privileges dictate which types of privileged actions your current access token allows. Now, what's interesting with privileges is that your token may have the potential to take on a bunch of privileges, but many of them will be disabled by default. To get some awareness of this, use WhoAmI whack priv. This will show you the privileges that are currently enabled in your token and the ones that are possible but currently disabled. To take on the full set of privileges possible in your token, use the getPrivs command in Beacon. So this is one form of escalating from a high integrity context where you have a lot of rights, but not the full set of rights available to you. 3 privileges you want to look for are SE create token privilege, SE debug privilege, and SE TCP privilege. These 3 privileges will allow you to do most of the things you may want to do on a compromised target. And if you don't have these privileges, you should expect that attempts to interact with certain process contexts, especially processes running a system, may fail. One way to escalate to the full set of privileges available is to try to take on the system token. The system token is an access token for the privileged system account on your computer. The get system command in Beacon will search for and try to impersonate a system token for you. Another way to try to elevate to a system context is to use the elevate service executable command. This will drop an executable to disk and create a service to run it, and that executable will run your listener. Let's take a look at escalating to system and working with getPrivs. So if we come over to our high integrity SQL admin beacon and interact, we can do WhoAmI whack priv. And this will show us the privileges associated with our current context. And you can see here's a list of privilege names, and a lot of them are disabled by default. Do you see what I mean? But it looks like we're actually in a pretty powerful context already because SE debug privilege is enabled. Well, if we wanted to, we could turn on all the privileges by doing getPrivs. And there's a list of privileges that were enabled. And if we do WhoAmI whack priv, you can see that most of these privileges are now enabled. So that is an example of getPrivs and how that works. And if you find that some things are failing when you expect them not to, try out get privs and see if that change makes a difference. The other thing I wanted to show you is elevating from a high integrity context to system. So let's do that. We're going to just do the service executable elevate option, and we will do our TCP beacon. And when our beacon checks in, there we go. We now have a beacon running as the user system. And this is a very powerful context where we should be able to do most things from. I do want to close this demo and discussion of Get System with one very important point. Get System and elevating to a system context is very much optional and not usually required. Oftentimes, the high integrity context you end up in will be good enough to meet your objectives. Of course, when I talked about UAC, I brought up some of the caveats of the different elevation options and how they can put you into a elevated but restricted context. When you end up in a place like that, Get System or Elevate Service EXE are wonderful tools. But remember, only use these tools if you need them. If they're not required, don't worry about it. So what can you do from an elevated context? Well, when you're elevated, you have more opportunities to change the system and install persistence, if that's your objective. You also have more opportunities to recover credential material. The hash dump command in Beacon will dump the password hashes of local accounts on the current system. The logon passwords command will run a Mimikatz module to try to recover plain text passwords and domain user password hashes out of LSAS. When you use either of these commands, the recovered credentials will show up in Cobalt Strike's credential data model. Go to View Credentials to see these. Let's take a look at logon passwords and hash dump. So if we go to View Credentials, you can see our credential model is empty. Let's come over here to the system beacon, and we will do hash dump to recover the password hashes of the local accounts. So that's what's going on there. And if we come over to credentials, we can see that Cobalt Strike's credential model is populated. By the way, you can right click and color code some of these as well. For example, I might gray out the guest account because it's useless to me, as an example. All right, let's take a look at running Mimikatz. So let's do logon passwords. And you can see we should have the domain user password hash for Jim Stevens and SQL admin is what I expect to see. Scrolling through all this output. Yeah, there's Jim Stevens, there's his domain user password hash. If we go over to credentials though, we can see what Cobalt Strike captured. Let's sort by Mimikatz, and we can see there's SQL admin, there's Jim Stevens, and from some other things I was doing earlier, there's the administrator account as well. Both logon passwords and hash dump inject into LSAS, and that is very risky. I want to share a few alternatives to both commands. You may find they are useful to you as is, and that's fine, but be aware there are other ways to accomplish the same thing. For example, part of the GhostPack repository is a tool called SafetyCats, again written by Will Schrader. SafetyCats is an alternate way to recover credentials with Mimikatz. SafetyCats and the logon passwords command of Mimikatz exposed in Beacon read the memory of LSAS. They do it in different ways, and that's why SafetyCats is interesting. Rather than call read process memory, SafetyCats uses a Windows API to dump the memory of LSAS to a file and process it with Mimikatz in memory. This different from expected approach is why SafetyCats is potentially an evasive option. Safety Cats is a very cool option. The one thing I want to point out is that it does not ship with the current version of Mimikatz. So if you're going to use it on an up-to-date Windows 10 system, you need to compile Mimikatz and recompile it into Safety Cats to get the full benefit of this very useful tool. Another option I raise, just to expand your mind on how to recover credential material, is internal monologue. And this is a tool and technique that can help you potentially recover the plaintext password of the current user. Internal monologue is a way of using a Windows API to issue a challenge for authentication purposes to the current system and to get back a response that is encrypted with a salt of your choosing. And by doing this, you may be able to get back an encrypted blob that is favorable to cracking offline. What about hash dump? You can use DC sync if you happen to be in the context of a domain administrator to try to recover password hashes for domain user accounts. And DC sync does not touch LSAS. Instead, it calls APIs meant for domain controllers to talk to each other to replicate information between themselves. If you want to recover the password hashes of local accounts, you can use Mimikatz LSA dump : SAM. And this will pull the password hashes of local accounts out of the registry. I've mentioned it a few times already, but I would like to talk about Mimikatz and Beacon. Mimikatz is an open source post-exploitation tool set developed by Benjamin Delpy primarily. And it is an absolutely amazing capability. It includes tools for advanced persistence. It includes tools to harvest credential or trust material and tools to repurpose that material. The Mimikatz command will run Mimikatz in a temporary process. If you prefix a command with an exclamation point, Beacon will ask Mimikatz to elevate to system and then run the specified command. If you prefix a command with the @ symbol, that will run Mimikatz in a temporary process, but also communicate your current access token to that temporary process. If you want to learn what is possible with Mimikatz, I recommend you take a look at the documentation on the Mimikatz wiki. And also, don't be afraid to dig through the source. Sometimes Benjamin Delpy's cryptic tweets and the source code are the best ways to understand what Mimikatz can really do. In this lecture, we talked about different options to elevate within Beacon. We talked about the elevate and RunAsAdmin commands and the elevate kit. We talked about how to use SharpUp to identify misconfigurations and act on them. And we talked about how to elevate with credentials. And I also showed how to grab credentials, potentially, with Kerberoasting. We then talked about two subsets of the privilege escalation problem set: bypass UAC and elevating when you're in a high integrity context to a context that has more rights. We also talked about how to recover credential material once you're elevated. We talked about Beacon's logon passwords and hash dump commands and alternatives to both. I also took you through some tips on how to get the most from using Mimikatz in Beacon. This concludes Part 7 of Red Team Operations with Cobalt Strike, Privilege Escalation.